Today's lesson is dealing with multiplying and dividing numbers written in scientific notation. If you look at the following string of numbers, 1/2 times 15 times 18 times 1/5, if you're asked to do that in your head relatively quickly, if you were to multiply them in the order that they are written, that would be a little bit difficult to do. However, if you remember under the commutative property, you can change the order as long as it's all multiplication or if it were all addition. So instead of writing it in the string it's written here, I would prefer to multiply 1/2 times 18 and 1/5 times 15. Why? Because 1/2 times 18 is 9 and 1/5 times 15 is 3. And now I've got my answer of 27 without really having to do that much work. The reason that concept is important is how it will apply to the multiplication and division of numbers written in scientific notation. One of the other main points here is that 3 times 10 to the 4th and 7 times 10 to the 5th are very large numbers. And it would be pretty cumbersome to write them out in standard form to figure out what their value is. And that's the whole point of scientific notation. So if you're asked for the product, which means to multiply, of these two numbers, what you can simply do is mix up the parts so that you have the numerical parts together and the values that are in base 10 together. Well, now all you have to do is multiply 3 times 7.1 to get 21.3, and 10 to the 4th times 10 to the 5th, using your laws of exponents, is 10 to the 9th. And the last thing you have to recognize is that this is still not in scientific notation because 21.3 is greater than 10. So I need to move that one decimal to the left, which means I have to add 1 to my exponent to get my final answer. Now, in the second example, you are asked for the quotient. You have to remember that quotient means to divide. So I'm dividing these two numbers. It's visually easier to see when written in a fraction bar. Well, I could divide these in pieces. 6 divided by 3 is 2. 10 to the 8th divided by 10 to the 5th, you subtract the exponents. And now you very simply have an answer without having to do all of that much work. So, what would you do if one number was in scientific notation and the other was in standard form? Well, the simplest thing to do would be to convert the number that is in standard form to scientific notation. Because as we've said, working with the numbers in scientific notation is significantly easier to do. So let's go to the next example. We're talking about world population of being 7 billion and that there are 4.6 times 10 to the 7th ants for every human. So if you think about it, for every one of us is some number, very large number of ants, which is pretty scary. I want to know how many in total. You should think of that as a multiplication problem, because if there's a certain number for one of us, to find out how many there's for all of us, I would need to multiply. Well, before doing that, I have to convert 7 billion, and I'll write 7 billion into scientific notation. Well, that means there's 9 zeros. And now I can just multiply these two numbers. I can then mix and match. The parts. I can multiply 7 times 4.6 to get 32.2. Add my exponents. And hopefully you realize that I'm not done, because 32.2 is not proper scientific notation. Since I moved 1 to the left, I add an exponent and get my final answer. Okay. Number 4. A social media company processes 990 billion likes per year. They have approximately 8.9 times 10 to the 8th users. About how many likes per is each user responsible for? So I want to know how many likes per user. You should always think of per something, meaning I want to divide it up amongst each person. So I want to divide these likes up between the number of users. Well, 990 billion, you have to be careful. We know billion means 9 zeros, but I still have 2 decimal places, so it's 9.9 times 10 to the 11th. So I want to divide the likes by the users. I'm going to use approximation here. 9.9 divided by 8.9 is approximately 1.1, and 10 to the 3rd power. Well, this is nice because it already is set up for us in scientific notation form. Now I want the answer in standard notation. I move the decimal 1 place to the right and add 2 zeros. Okay, so 1,100 likes per user. Now, the next 2 problems. If you read practice problem number 1, and as I switch to it, give me 1 second. It says the speed of light is 300 million meters per second, and the distance from the sun to the earth is 1.5 times 10 to the 11th meters. How many seconds does it take for the sunlight to reach Earth? If you're dealing with a distance problem, you want to keep in mind the following formula. Distance equals rate times time. Okay, D is distance, R is rate, and T is time. And you want to be able to identify in this problem which of these 3 you have, so as to be able to figure out whether you're going to multiply or divide to be able to solve this. So the speed of light is 300 million meters per second. That's the rate. The sun is approximately 1.5 times 10 to the 11th meters from the earth. That's the distance. What my unknown is the time. So I want to solve for time. Well, I can manipulate this to figure out time. Time is distance divided by rate. Okay? So going back to the original problem, the distance is 1.5 times 10 to the 11th. The rate, 300 million meters, is written as 303 times 10, and we want to convert that to scientific notation. That's 10 to the 8th. 1.5 divided by 3 is 0.5. Subtract your exponents. Again, not in proper scientific notation. I move 1 to the right, so I remove 1 from my exponent. So it takes approximately 500 seconds for light to reach Earth. Okay? If we look at the final problem, the mass of the moon, 7.3 times 10 to the 22nd. There are approximately 26 million moons, equal to the mass of the sun. What's the mass of the sun? Well, 1 moon is this. There's 26 million of them to equal the mass of the sun. To figure out what the mass of the sun is, I need to multiply. So I convert 26 million into scientific notation. That would be 2.6 times 10 to the 7th. I'm going to multiply that number by one particular moon, again, I can mix and match what I'm doing here. So I'm going to do 2.6 times the 7.3, which gives me 18.98. Sorry for walking away there for a moment. And then 10 to the 7th times 10 to the 22nd. So I get 1.898 times 10 to the 29th. I'm sorry, not 1.898. I was a step ahead. It's 18.98. One thing you should get into the habit of, it's 7 times 2.6. You can round that to 7. You can round that to 3. Your answer should be somewhere in the range of 21, a little less because you rounded this up more than you rounded that down. So that gives you an idea of whether when you do this, the number makes sense. Not in scientific notation yet. Make it smaller, make that larger. So to summarize, when you're multiplying or dividing numbers in scientific notation, it's much easier than adding or subtracting because the exponents do not need to be the same to be able to do this. You don't have to equalize the exponents like you did in the other lesson, and you just can mix and match the parts to be able to do your multiplication or division.